Hey, this is a follow-up video for that original 6S2P do-it-yourself lithium-ion pack video. So, after publishing that video, I started thinking and wondering about that safety of the pack and how it would handle the high current pulse from the pack. So I did some research and exploring more and came to the conclusion that I want to rip that pack open again and make it a little bit better and enhance it much more. This is not a tutorial video, this is just a new video of me going back to my old work, revisiting it, opening it up and explaining to you what I did to change it.
When I opened the pack again, nothing was technically wrong, the welds were solid and the pack would have worked. But for a long-range lithium-ion pack, especially 6S2P, I realized I wanted more current handling headroom and more mechanical redundancy. So I decided to add a second layer of nickel-plated steel strips. On top of that, I added copper push bars to lower the resistance and spread current more evenly. Instead of buying pre-made push bars, I made my own. I twisted two 2.5 square millimeter copper wires together, flattened them slightly and soldered them onto the second nickel steel layer. After letting everything cool down properly, I then spot welded the reinforced strip on top of the original connections. So the final structure is now two layers of nickel-plated steel reinforced with copper push bars. The goal here wasn't a maximum current at all costs. It was a margin. Lower resistance, better heat distribution, and bit more peace of mind for long-range flights, where you don't get a second chance. Some of you also pointed out similar concerns in the comments, especially about heat under load, which just confirmed that it was worth taking a second look.
I want to be clear on one thing. I think that the first build version wasn't dangerous, but I think that this new build with those copper linings and push bars inside of this makes it a whole lot better to the use how I'm going to use this pack. And now I can be confident that those current paths won't be eating this protective lining on top of this. And this pack would handle the high currents that these cells contain. And if I want to pull them, this pack can give them to the drone. And I think it's important to say this out loud, that revisiting your own build videos isn't a mistake. I think it's important to show people that if you think that there is a way to make it even better, you should show it. And not just pretending that I would leave that first video and pretend that that would be perfect. So I'm happily to do this follow-up video to show how I made it even better, that pack, and show you guys that this is how I made it, and this is how you could also make it if you wanted to. So, if this video helps even one of you guys out there to think about their own lithium-ion packs, their safety margins and their current paths, then I think this was totally worth it. So, next we have to test this on the flight, and that would be a topic for our next video. So, I see ya.